Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19. And we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include a, s, v, and u? That's got a t in it, that's got a t in it, so it's going to be this one here. So let's write that out. V squared equals u squared plus 2as. So that would be 34 squared equals u squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places. So it's going to be 25.73. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared, and 49 squared is 2401, and 68 squared is 4624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2401 from both sides. So we've got b squared equals 2223. Then we're going to square root both sides, and we've got b equal to 47 33.148, blah, blah, blah. Okay, we're now looking at the second diagram, and this time we're going to have A, we've got our B, and we're going to call X the C. So it would be A squared plus B squared equals C squared, but this time A is 39. B we are given as 47.148, we've just worked that out, and we're looking for C. In fact, we can call it X now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to X squared. And we just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to X. It says it wants its two decimal places, so that will be 61.19. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint, so our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5, and we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT, and so we're going to just add this column up here, and so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement, and we're going to do 105 take away the 93.125, and that's going to be 11.875. Now it does ask for two decimal places, so that will be 11.88. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus, and so we've got 12X, and then on the last bus stop 19 passengers get on, so plus 19. Now for the second bus, well, we start with X and a further 5X come on, because 5 bus stops with X passengers, so that's 6X altogether, and then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less, and the way we show that is with this inequality here. Now all we need to do is solve that inequality, and we've got x on both sides, so we look at the x's. We've got 12x and 6x, so we always take away the smaller amount, so we're going to take away the 6x both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got x is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for x? Now, it is tempting to write down 10, but it says x has to be less than 10. So the biggest number we can get that is less than 10 is 9. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. Try to get x on its own, and we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69. Because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down. So it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. and 9 times 10 to the power of 4 would be 90,000, so that would be 9,0,0,0,0, and so we're just subtracting them like that, and so we'll get 6,991,0,0,0,0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here and here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by minus 3. They're minusing 3 each time. So we know that the number before the n is going to be minus 3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3 and we would find it to be 20. So whatever numbers are 0th term, because 17 is our first term, is going to be what we add to the minus 3n. So it's going to be add 20. So our answer is minus 3n plus 20. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement and we're just going to go through each of the corners of our shape A, and we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. To solve this, we've got to first of all factorise the left-hand side, and so we look at the number, and it's definitely a difference of 2 squareds. So x squared the square root of that will be x, and we think about what the square root of 144 is, which is 12, and so we plus 12 and we minus 12. So difference of 2 squares, you take the positive and the negative root. Now to solve, one of these brackets is going to equal to 0. So we're going to do the first bracket equal to 0. So we've got x plus 12 equals 0, and we're just going to put our lines down and take away 12 both sides, and we get x equals -12. So one of our solutions is -12, and we do exactly the same thing to the other bracket. So get it equal to 0 and solve. So add 12 both sides. You'll notice something about the numbers here, that they are just exactly the same. And that's because when you find a solution, you get the number here and you just change the sign. So that becomes -12 and that becomes +12. First thing we notice in the simultaneous equations is the coefficients, the x and the y's are different. We could make the x's the same, but I'm going to focus on the y's. So looking at the coefficient of the y, we've got a +3 there. We've got a -5 there. So ignore the signs, we've got to make them the same. So 3 and 5, we're going to look at the first number in both their times tables, the lowest common multiple. So that's going to be 15. So I'm going to rewrite the first question. So 2x plus 3y equals 12. Get my solving lines in. And I'm going to times everything by 5 to make that coefficient of the y to be 15. So we're going to make them equal. So 2x times 5 is 10x plus 15y, which is good, that's what we wanted. And then 12 times 5, which is 60. Right in the second equation, 3x minus 5y equals -1. And this time we're going to times everything by 3 to make that coefficient of y to be 15. So 3 times 3 is 9x, minus 5 times 3 is -15y, which is good, that's what we want. And then -1 times 3 is -3. So we're going to rewrite those again. And the 9x minus 15y equals -3. Okay, so this time it's simultaneous equation, so we know we're going to go downwards. So we get these circles in, make sure that the signs are with the coefficients of the y. And we've got to either add or subtract going downwards. Now, the way of knowing is we look at the coefficients of the one we've made the same, so the y, and we've got a +15 and a -15. If they are the same sign, then we're going to subtract. If they're different signs, we're going to add. So S in same is S in subtract, D in different is the D in add. Looking at them both, there's a +15 and a -15, so they are different. So we're going to add. And we don't just add those ones, we add all of them. Now we're going to go down the page, which we always do with simultaneous equations. And we're going to work out the sum of them. So 10x plus 9x is going to be 19x. 15y plus minus, well plus minus just makes a minus, so it's 15y minus 15y is 0, which is good, that's what we want. And then 60 plus minus, which makes a minus, so 60 take away 3, which is 57. Then we're going to do a quick bit of solving by dividing both sides by 19, get x on its own. And so we get x equals 57 divided by 19, which is 3. But that's only half the question. We need to find out what y is. So we're going to substitute that into the very first equation we've got. And so we're going to do 2 times the 3 that we've just found, plus 3y equals 12. 2 times 3 is 6, so take away 6 both sides, and we get 3y equals 6. Divide by 3 both sides, and we get y equals 2. And we can substitute those into the second equation to find out whether it equals -1, which it does. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be -4, and 11 take away 14 is -3. Then I go pick a point on my shape, and the bottom, or the top one, tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a -3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. It doesn't look like it, but we actually have a quadratic here. And the reason it doesn't look like it is because we don't have an x term. But as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down 2 sets of brackets, and you square root the first term. Well, that's just going to be x. And you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we're just going to quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. So the angle of elevation is when you are looking horizontally, like here. It's the angle that you have to look up to see something, so that castle. So this is the angle of elevation here, which I'm just going to call x. And we've got a right angle triangle here where we have two lengths and we're looking for an angle, so we're going to be using trigonometry. So we're just going to label this up. So we've got the opposite here, adjacent to here. We don't need the hypotenuse at all, so get rid of that. Let's just put our SOHCAHTOA in. So we've crossed out the hypotenuse, so it won't be sine or cos, it will be tan. So it would be tan x is equal to the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan of both sides. And so the inverse tan of 49 over 98 is 26.565, etc. And it says it wanted the nearest whole number, so that will be 27 degrees. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. We're going to first of all multiply the coefficient of the x squared, which is 6, with the number on its own at the end, which is -5, and that will give us -30. And the special thing about this number is we're looking for two numbers that times together to make that number, and we're looking for two numbers that add together to make the coefficient of the x, which would be 13. Now, to make a product that's negative, we know that they're going to have to be different signs. So one will be positive, the other will be negative. And we can do this in our head, or we can write out the factors. So I can just quickly write out the factors of -30. So it would be -1 and 30, -2 and 15, -3 and 10, -5 and 6, and then the same thing just the other way around, so 1 and -30, 2 and -15, 3 and -10, and 5 and -6. And we're looking for the pair of numbers that add together to make 13. So just looking down the list, this one here will make 13, won't it? Because -2 plus 15, or 15 take away 2, is 13. So the two numbers we're looking for are +15 and -2. I'm going to rewrite the question now, but instead of the +13x, we're going to split it up into the +15 and -2, or the other way around. So we could do 6x squared -2x +15x -5. And a little tip, if you've got a positive and a negative number, let's just tidy that up a bit, always put the negative number first. Okay, so always, if you've got a choice, put the negative number first and then the positive number. It just makes the maths a bit easier. We're going to look at the first two terms and the second two terms separately. We're going to factorise them linearly, which means just put them into a bracket. And we'll only look at the purple box. So here we've got 6x squared minus 2x. So that's obviously going to be 2x on the outside. And that's going to be 3x minus, and here it's actually just going to be -1, isn't it? Okay, and for the next one, we're going to have, was it 5? And that would be 3x, and again -1. Okay, these two brackets, it's not a coincidence they're the same. They have to be the same, and we just write them once. They are one of our brackets. If they're not the same, it means you've made a mistake somewhere. And we get the 2x and the +5 together. So 2x plus 5, we put them together. So in total, we have the first bracket, which is 2x plus 5, and the second bracket, which is 3x minus 1. And actually, the brackets can be either way around. I'm going to start by labeling this triangle. And so I'm going to pick a lowercase a here, uppercase A, I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice and easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah, blah, blah. And when we round that, we get 2.68. Now this question is on the calculator paper, so we know we're going to be using the quadratic formula because it asks us to leave our answers to 2 decimal places. So for the quadratic formula, we need to work out what a equals, what b equals, and what c equals. Now a is the number before the x squared, which would be -2. B is the number on before the x, which would be 13, and c is the number on its own, which would be -17. We're going to write out the quadratic formula, so it's x equals minus b. Now I always put these into brackets, so I'm going to first of all just do the fraction first, just so we've got nice formatting on it. So we're going to have minus brackets b plus minus the square root of brackets b squared minus 4 times a in brackets times c in brackets. Okay, and the reason we put the brackets is that it's very, very easy to make mistakes with the negatives. And so if you put all the numbers in brackets, you'll never make that mistake. And it's going to be over 2a, so that's 2 times -2. We're going to first of all put that into our calculators with a plus there. And when you do it with a plus there, you get 1.813, blah, blah, blah. And then what you're going to do is use your calculator to go back to this and change it for a minus. And when we do that, we get 4.686, blah, blah, blah. And so to 2 decimal places, we've got 1.81 and 4.69. If we start by labelling the sides and angles on this triangle, so we can have capital A there, little a, capital B up here, little b, then capital C here and little c. So we don't have the angles A and B, and we don't have length C, but we do have little a, little b, and the angle C. And there's a nice little formula to work out the area of this triangle, and that formula is half a, b, sine c. It's a nice little formula. And so we're going to do half times a, which I've said is 5, times b, which I've said is 4, times sine the angle, which is 24. And when you work that out, you get 4.067 blah blah blah. And when we round that, we get 4.07. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed, and all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'll be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now, so it's y equals 3,430 over x cubed. And that actually is our answer. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference. And the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should re-put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. To answer this question, we're going to do something a bit weird on the calculator. And this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution. And you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this: the cube root, and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398 blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it will be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309 equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x, so half of the 10 would be 5, close bracket, squared. Now I'm going to leave that half done, because down here I'm just going to, or across here, I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. I'm going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now, the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. To solve when we've got two equations that aren't linear, and here we've got a linear and a circle equation, what we're going to do is we're going to solve by substitution. We're going to substitute one into the other. So here we're told that y is equal to 3x plus 11, and we actually have a y in our second equation. So what we're going to do is just substitute it in. So we've got x squared plus, and instead of y, I'm going to say what the first equation is. I'm just going to replace it for what y equals in the first equation, which is 3x plus 11. And it's y squared, so it's that squared, equals 125. Okay. Now we need to expand the brackets there. And so we're going to have x squared, and you can use any method you want. And don't forget, when you square brackets, that's just going to be 3x plus 11 brackets 3x plus 11. So we're going to do 3x squared, which is 9x. So how are we going to write this? So plus 9x squared. And then we've got 3x times 11 plus 3x times 11, which is 33x plus 33x, which is 66x. And then we've got 11 times 11, which is 121. Now at this point we want everything to equal 0 because it is a quadratic. So to solve it we need it to equal 0. So we're just going to tidy it up and add the bits that need to be added, and we're also going to subtract 125 both sides to get it equal to 0. So x squared plus 9x squared is going to be 10x squared. So we might as well just write it as 10x squared. We've got 66x just on its own. And we've got 121, take away 125, which is minus 4, equal to 0. Now it says it wants our answers to 2 decimal places, so chances are these won't factorise nicely, so we're going to be using the quadratic formula. And so we need to find out what a, b and c are. So a is the number before the x squared, the coefficient of the x squared, which is 10. B is the coefficient of the x, which is 66, and c is the number on its own at the end, which is minus 4. The quadratic formula will be minus b, and I always put the values we substitute into brackets, because if they're negative that really helps us, plus minus square root of b squared minus 4 times a times c, all of that over 2 times a. When you put that as a plus, then into the calculator we get x equals 0.060 blah blah blah, and when you put a minus there we get the answer of minus 6.660 blah blah blah. Now you might think, well, how are we going to find out what the y's are? Well, if x is 0.06 blah blah blah, we've got an equation here that says to find out what y is, we times the x by 3 and we add 11. So we're going to times that first solution by 3, then add 11, and that gives us that y is 11.1 180 blah blah blah. We're going to do that with the next solution, and we're going to times it by 3 and add 11, and when we do that we get minus 8.980 blah blah blah. We're going to round each of these to 2 decimal places, so we've got 0.06 and 11.18, and the second set of solutions is minus 6.66 and y equals minus 8.98. So we're asked to first of all complete the square, so that's what we're going to do. And to complete the square we've got to remove the minus from the x squared because we've got to have x squared, so we're just going to factorise out the minus 1 effectively. We have minus x squared, and this has to be minus 10x, and then we're just going to leave the plus 7 on its own at the end there. And the reason this is a minus 10x is a minus 1 times minus 10x is 10x. Okay, so we're going to leave that, and we're going to just focus on the x squared minus 10x. So the way we complete the square is you do a bracket and you have x, and then you halve what the coefficient of the x is, so that'd be minus 5, and then square it. Now if you expand that you get x squared, brilliant, minus 10x, fantastic, plus 25, right, we need to get rid of that 25. And so I'm going to now expand the bracket with the minus on. So we've got minus x minus 5 squared plus 25 plus 7. And then we're just going to add the 25 and the 7, and you should get 32. Now if I'm to draw the graph of y equals minus x squared, it's just a graph that looks like this. But more importantly, that their maximum point on this graph is at 0, 0. And if we remember our graphic transformations say that if we have a minus 5 on the inside of our function, and so comparing this function, say this is f of x, part of this equation here involves a minus 5 inside the function. That minus 5 moves the graph to the right 5. Okay, so we're going to move it to the right 5. Similarly, if you have a function and you've got a plus 32 on the outside of it, which we have here, it's going to move it up 32. So instead of our maximum point being at 0, 0, it's moving to the right 5, so the x coordinate would be 5, and up 32, so the y coordinate would be 32.
You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.